Hello everyone, welcome back to another tutorial. In this tutorial, we are going to talk about the unit impulse signals. So by definition, when we talk about the unit impulse signals are zero, but at n is equal to zero, they have the amplitude of one. So these are also called direct delta functions. So unit impulse systems play a very vital role in the LTI systems to check the impulse response of a system. When we will be discussing about the convolution sum in our tutorials, I will tell you what is the unit impulse system and how unit impulse functions are being utilized in it. For now on, you just need to simply focus on the basic definition of the impulse signals. And from by definition, very simple method to remember it is that at n is equal to 0, they have the amplitude of 1. So they do not have any other values here. So if you can see from here in this region, these are I will make a zeros vector here, and then again I will use a zeros vector here as well. Okay, and only at the sample where n is equal to 0 will have the amplitude of 1, I will only plot it there. So let me take you to the MATLAB environment. So in MATLAB, you just simply have to do the basic drill, CLC, clear all and close all. I'm very fond of these three lines because these reduce the chances of error to the zero. So CLC command clears the command window, clear all command clear the workspace, and close all command closes all the existing MATLAB commands. So I have ran it here. So my command window is clear, my workspace is also clear. So since we are talking about the unit impulse signals, so unit impulse signal only have the value of 1 when the time or sample is equal to uh, 0. So it will have their value. So there is no uh, specific agenda in making the continuous time unit impulse function or discrete time unit impulse function, but make it concise for you guys. I am going to use both approaches. So let me define time. As I have been taking the same time minus 1, minus 10 to 10, step size of 1, and the signal. Okay, let me initialize the signal. Now here I will have initialized an array, but in this array there will be a different approach as compared to my previous tutorial. In my previous tutorial, we were developing unit step signals and they had the different scenarios. But from this purpose, we have to make a signal which only has the one value when the time is 1. So for that purpose, I have to define a row matrix of 1 cross 10. Okay, 1 and zeros, 1 cross 10. Okay, fine. Now my array is complete. From here you can see that the first 10 elements will have the amplitude of 0, then 11th element will have the amplitude of 1, and the next 10 elements will have the amplitude of 0. So from here you can see that I have defined my vectors in a form that when I will plot these will definitely result in the form of unit impulse signals. Okay, now to plot it, I am going to use the hold on approach. In my previous tutorial, you have learned how you can use the hold on approach, and to keep it very simple for you guys, I am writing it as time comma signal. On the x-axis we have our time, and on the y-axis we have our amplitude. And to make it discrete, I will use the variable name time, but in this case it will be behaving as a sample. So stem time comma signal. Okay, fine. And I will give it title in which I will write unit impulse signal. Okay, and x label, in x label I will write samples, and in my y label I will write amplitudes, and I will include the legend as well. In legends, I will initialize the continuous, and the next I will show you as a discrete. Okay, I will include the grid command as well. I have grid on command here, and I will change its color to red. Okay, and I need to put an comma here, and also I will change assign it a maroon color. So let me check if it works. Okay, fine, we have it complete. So let me run this and let's pray that there is no error in it. Definitely there will be no error. If there is any kind of error, we can simply resolve it. So now, okay, fine. Oh, what a beautiful graph it is. So we have made our unit impulse signal in MATLAB. So just focus on this purple or maroon color line. Do not focus on this red line. I will discuss about the red line later. This is for the discrete time. So in the discrete portion, we can see that our signal from -10 to 1 has nothing to show. And in the same case, when the time passes the sample, when the sample 0 is crossed, it has amplitude of 0. But at 0, it has the value of 1. Okay, so it is a very accurate unit impulse signal. In the case of continuous, you can see that there is this slope, a minor slope here. Do not worry about it. Basically, when we draw on these on 2D plane with by hand, so we usually ignore those samples between 0 and 1. But when we talk about the software approach, so it has some values in continuous time. Those are in between 0 and 1. Okay, so in theory we ignore those values, but while we are working in a software environment, we cannot ignore those values. It has nothing to do with our models. It has no impact on the performance of our models, but simply this is only for the sake of visualization purposes. You can simply ignore it. Okay, because that was a continuous time signal, and in continuous time we have no gap in time intervals. In continuous time, our values exist on every possible decimal point. So that's why these lines are here. So you can simply ignore it. By writing these just few lines of code, you can amazingly make unit impulse signals in MATLAB. So hopefully you would have liked this video. If you have any questions regarding this tutorial, you can simply ask me in the comment section, and see you in next tutorial. Thank you so much.